When dividing polynomials, it is often easier to use synthetic division when it is appropriate to do so. It's a quick way to perform the division of polynomials with the possibility of very few missteps, unlike long division. We can use synthetic division to divide two polynomials whenever the polynomial we are dividing by is of the form x minus c. Now, that does not mean that you'll always see x minus a number, but you will always see x minus a number or x plus a number. So the easiest case would be to look at this first polynomial divided by x minus 6. In this case, we're dividing by x minus a number, and the number we're subtracting from x is 6. So c would be 6 in this case. So we can clearly use synthetic division to divide the polynomials. Whenever we look at this next division problem, we have a fifth degree polynomial divided by x plus 4. Now, we can still use synthetic division in this case, simply remembering that x plus 4 is the same thing as x minus negative 4. So in this case, c would equal negative 4. Another way that a division problem could be written is as a polynomial divided by another polynomial in a fraction. So in this case, we have a fourth degree polynomial divided by x minus 8. So in this case, c would equal 8. C would equal 8. So let's look now at an example. So the way we set up our synthetic division problem is to set up 3 rows. So the dividend corresponds to the numbers underneath this division symbol. So the coefficients of the dividend are 2, 4, negative 3, and negative 5. We've already said that here c would equal 6. So that number, 6, goes outside. We now reserve 2 more lines underneath this first line. So we will have numbers that will be here and numbers that will go here. To determine the first number in the third row, we will simply bring down the first entry in the first row. So 2 will come down, and that will be our first entry in the third row. Now the question is, what will go here? To determine that number, we multiply our value of 6 by this entry 2. So 6 times 2 is 12. To determine the next number, which will be in the third row, we add the entries that are above it in this column. So we will take 4 plus 12, and we will get 16. Now we will repeat those steps over and over and again until we are finished by placing a number in this entry. So we have the need for an entry here, so I will multiply 6 by 16 and obtain that number and place it in this entry. So 6 times 16 is 96. And then we go ahead and add the numbers in that column to obtain the third row entry. So we obtain 93 when we add. Now, we will find the entry in the second row in the last column. And so to obtain the entries in the second row, we will always multiply the value of c times the preceding third row entry. So that will be 6 times 93, and we will obtain 558. So we will place that in the last column. Now, to obtain the entry below that, we go ahead and add. And negative 5 plus 558 is 553. At this point, some teachers like to go ahead and block off this last entry, because this entry is the remainder. These entries, the 216 and the 93, these are the coefficients of the quotient. Now we took a third-degree polynomial and divided by a polynomial that was a first degree. So this is like taking an x cubed, dividing by an x, and that's going to leave us with an x squared polynomial. So the quotient will be a quadratic. So we have 2x squared plus 16x plus 93 is our quotient. Now whenever we write the answer to a division problem, our answer will be quotient plus remainder over the divisor. So in this case, our quotient is 2x squared plus 16x plus 93 plus the remainder, which is 553, divide by the divisor, which was x minus 6. And thus ends our problem.